Hello, and welcome to this lesson in quantitative reasoning where we talk about the mathematics of finance. We're going to talk a little bit more about percentages and discounts and sales tax and how to apply it. So this slide was provided by our textbook publisher, and we're going to learn about applications. Now, a lot of times when you deal in finance is an application. It uses math as a tool. So we see applications, it's kind of code word for word problems. You can't say, oh no, I don't like word problems. Life is a word problem, so we're going to learn how to deal with that here. We're going to learn how to read the words and what they mean. So we're going to solve applications with discount or markup and determine the final cost of an item after we do sales tax and discounts on it. So, applications of a discount are common in retail settings. Sale, 20% off. You hear things like that all the time. When you buy an item on sale, the original price has been discounted by some dollar amount. They usually tell you it is a percent, though. Sometimes they'll say, take $5 off, take $10 off. But most of the time, it's like 20% or 10%. So the amount of the discount, how much you're getting taken off, if you're given the discount as a percent, is the discount rate, the percent written as a decimal, or percent if it's 20%. Remember, we talked about how you replace that with 20 divided by 100. And that's what you put here for the discount rate times the original price. Now that will give you how much money is taken off. So to find how much you have to pay, you have to do the original minus the discount. There are other ways to do this too. You could do the amount left is 100% minus 20% and say, well, I'm going to pay 80% of the original. And whenever you see the word of the original in this context, when you see the word of in relation to percents, it means you're going to multiply. So you're going to do 80 over 100 times the original price. So that will give you the new price. But if the other way to do it, and most students seem to understand this, is you find out how much you're going to save by doing the percent they're taking off times the original price and then subtracting that from the original price. So, Jason bought a pair of sunglasses that were on sale for $10 off. It's $10 off. So this is a case where they told you the dollars off. The original price was $39. What was the sale price? It's $29. It's $39 minus the 10. They give you dollars off, and you get dollars. Dollars minus dollars is dollars. If this were 10%, you would have had to do a calculation to find out how many dollars off 10% is. So, applications of a markup. You buy something wholesale, you mark it up to sell it at a profit. The retailer pays wholesale price, pays an original cost, and then they have to add a markup to get a price to sell it at to make some money. So, it's usually a percent of the original cost. And to determine the amount of a markup, you multiply the markup rate by the original cost. So, if you know you want to make a 25% profit on something, you're going to take 25%, that's 25 out of 100, or 0.25 as a decimal. This is where fractions and decimals equivalents are important. And you're going to multiply it by the original cost, and then what you're going to charge the customer is the original cost that you paid for the item plus the amount of the markup. It's just like a discount, only you're adding instead of subtracting. So Adam's Art Gallery bought a photograph at an original cost of $250. And then he marked the price up 40%. Find the amount of the markup, that's related to the 40%, and the list price. You're going to have to add the 40% to the $250. So 40% means 40 divided by 100. That's what the percent symbol means. And that is the same as 0.40. So that is what we use here. 0.40 times 250 equals 100. That is the markup. So that's how much money Adam wants to make off of this photo. So that means he paid $250 for it, and he wants to make $100. He has to charge $350 for it. So if you run a business, this is very important to understand these processes and this concept. So, and the other thing is when I start this problem, this is talking about a markup. The original price was $250. I immediately should be thinking, should my answer be smaller or bigger than $250? It's a markup, so my answer should be more than $250. So if I accidentally calculated this 100 and said, oh, that's my price, I should go, wait a minute, that's not more than $250. And then I would say I hadn't quite finished the problem yet. All right, so here's another one. Andrew bought a shirt that was discounted 15% off the price of $40. What was the amount of the discount and the sale price of the shirt? So 15% is 0.15. That's 15. If you're wondering where that 0.15 comes from, 15% literally means 15 divided by 100. If you do that, you get 0.15. Your calculator will give you 0.15 if you do 15 divided by 100. Fraction bar is division. You multiply times the 40. That tells you they're going to take $6 off of the price. 40 minus 6 is 36. Another example. Our furniture store bought a couch at a wholesale price of $350. They want to mark it up 60%. I guess the markup on furniture actually is pretty high. Find the markup, the amount of the markup, and the new price of the couch, the list price meaning what they're going to retail it for. 60% is 0.60. You multiply that by the wholesale price, you get a markup of $210. $350 plus the markup gives you the $560 list price. I'm going through these kind of quickly, but you can stop the video at any time and look. You don't have to, just go with me. You can stop. We will now discuss the final cost of an item when it involves more than one operation. So this kind of goes back to what we've been doing already. They talked about percent is expressed as a fraction of 100. Whenever you see the percent symbol, the number before it, no matter what that number is, in this case it's 30, 30% means 30 over 100 is the number you're using in your calculations. You might have remembered, you might have learned this in prior courses, and you might have said, oh, you got to turn that to a decimal first. Well, yeah, this is how you turn it to a decimal, 30 divided by 100. So when you see 30%, that the number you're using in a calculation is this representation of the percent. So they talk about if the percentage of students who get an A in a course is 30%, that means if there were 100 students, 30 of them got A's. Now, if you had 500 students, for every 100, there'll be 30 with A's. 30% times 500 would give you 150 students with A's. So we've been using this idea. 30 was to 100 as really what you're doing is 30. It's a ratio. If I had 100, 30 would have got A's. Well, I had 500. So how many are getting A's? If you solve this, you multiply both sides by 100, and that's what you get. So those aren't two separate things. The proportion, the way that you can solve percentages with proportion too. All right, another example. This clothing store sells shirts for $20. They're on sale 15% off, which is going to be 15 over 100 is the number. Fractions are fine numbers. Don't avoid them. Now, you could first change that by doing the division in your calculator or knowing you just move the decimal 2 to the left to 0.15. So you could either use, so this will be 15 divided by 100 times 20. That works fine for order of operations. Or you could do 15 times 20 divided by 100. It turns out it won't make a difference. And you get $3. So this literally says 15 divided by 20 times, divided by 100 times 20, but either way it works the same. So the sale price, so if I'm taking $3 off and I started with 20, I subtract 3, I get $17 for my price. Now you have to add 6% sales tax. You add it to this price. You don't add the 6% to the $20. You find 6% of 17, which will give you $1.02 here, 6 over 100 times 17. So now your price of your shirt is $18.02. Okay, so the sales tax is on the new amount. It's not 6% on $20. It's 6% on 17. So that brings us to this idea. Can you combine discounts by adding? Well, when you take a percent of a percent, the second percent is on the number you get after you take the first percent. So a percent is a relative measure. It has to be related to some original value. So the first percent is related to some original value. And then when you do another percent to that, you're relating it to the new value. So the numbers are different than if you related it to the original value. So let's say a store had a rack where all sweaters in the rack were being sold at a 50% discount off the price on the tag. Then there was another sign of the rack that said save an additional 50% if you purchase with a store credit card. Are the sweaters free? Now, this example is extreme. More often it says save an additional 20%. What I want to point out is you don't save 70% off the original price. You don't save 100%, 50 plus 50. The first 50% is on the price of the sweater. The second 50% is not on the price of the sweater. It's on the new price of the sweater. So the sweater tag said $100. The discount, 50% of 100 is 50, so I'm going to either leave 50 or take 50, however you look at it. 100 minus 50 gives me $50 now. So I'm going to take this to checkout, and then I'm going to use my store credit card and get another 50%. It's not off the 100. It's off the 50. So 50% will be 0.50 times 50 will be another $25 off. I have a $25 final price, not a zero. The other way you can look at it is you multiplied the original times 50 once, you multiplied the original times 50 twice, and this is your new price. So this is the amount you keep, 50%. 50 is a bad example for this. If it had been 50 and then 20% off for using the credit card, you would have made this a 20% here, so the price would have been more. Or you could have done, okay, I'm going to keep 50%. The cost of the sweater is 50%, and I'm keeping 80% here. So I would have gotten a cost of $40 there. Okay? Not 30, which is what it would have been if you added the percentages. So the point is you do one at a time. And if you don't know, if the question was what percent of the original amount was there, you pretend whatever you were starting with was 100. And then you apply the percentages. And this would be 25% of the original amount is what you paid, because that number was 25 and I started with 100. So if they don't give you the price of something and ask you what percent of the original price do you pay, pretend the price was $100. The other thing where percentages are thrown at us all the time, politicians use this all the time. I just saw a recent example of it that made me sad. Economic data can be used to lie to you. Let's say the stock market or the gross domestic product or some other measure or of our economy's health dropped 30% in the second quarter of a year. And then in the third quarter of the year, it started to come back and it grew 30% in the third quarter of the year. You read these two numbers and you think you're back to the original level, but you are not. The first 30% was based upon where the market was at the beginning of the second quarter. The second 30% was a growth of a smaller number of where the market was at the beginning of the third quarter. So let's pretend. 100's a nice number to pretend with. I just want to know if I'm back to the original 100. I'm going to pretend the stock market was valued at $100. Now, that's ridiculous if you look at the different indexes, but let's just pretend, because that's a good number. We're just looking to see if I'm back to my original. It doesn't matter what the original was. So at the end of the second quarter, it dropped 30%. So I do 0.30 times 100, and I see, and this is 100, so I should know that this is going to be 30 anyway. I have to take 30 away. So 100 minus 30 is 70. Now the value of the stock market is $70. So now I watch through the third quarter, and I had a 30% increase. It's a 30% increase on the $70. So 30% of 70 is 0.30, or 30 over 100 times 70, and you get 21. That was the increase amount. It started at a base of what we called 70. 70 plus 21 is 91. I am not back to the full 100 yet. You think you take away 30%, you add 30%, you should be at full 100. The second 30% is based on a smaller number than the first 30%. You have to pay attention to this when people are trying to sell you ideas or get you to vote for them or make some sort of a contractual deal with you. You have to understand this to be a wise consumer. That if 30% down and then 30% up from that does not bring you back to your original level. All right, and here's some more practice determining the final cost of an item. An electronics store sells used computers for $250. The computers are 10% off, and then there's a sales tax of 9%. So I take the 10% off. I get 10% of 250 is 25. 250 minus 20. So this is my sale price. And then I put the tax on that, and I get $245.25. Now, a remote grocery store in a national park sells candy bars. You're out in Yellowstone National Park or somewhere, and they've got candy bars. So they buy the candy bars for 65 cents each, and they charge a 50% markup. This is true in most things. Like if you go buy a bottle of soda at a sub shop and you buy a single bottle of soda, it usually costs like twice as much as it does in the grocery store. Whereas in the grocery store, maybe you can get that bottle of soda for like $1.09. It might be $2.50. Or like bottled water, $4 at Gillette Stadium. Okay, for a bottle of water that you could probably get for, I don't know, 50 cents or less if you bought a stack of them at the grocery store. So anyway, 65 cents wholesale. The National Park buys them in bulk. It's 65 cents each. They charge a 50% markup, and then they add on the sales tax. So the markup on the candy bar, now you could find out the markup by just finding the markup and then adding it. Or you could say, well, I'm going to have 100%. Here's the other thing we haven't done too much, but plus 50% is going to be my cost. So that's 150% of 65 cents is what I'm going to pay. So that's 150 divided by 100. Your percentages don't always have to be less than, have a number on top less than, times 0.65, which is what I paid. And that would take you right to this 97.5 cents. So the price is 97.5 cents. Not sure how they charge you half a cent. They might just charge you 97. They might charge you 98. But let's add the sales tax in on that. And the sales tax was 4%, which is 0.04, not 0.4. That's why it's sometimes important to use this instead of moving the decimal place, because we don't always move it enough. So I get a 0.039 cent, another fraction of a penny. It's okay because I'm going to add, and I get $1.014. I'm going to round that in dollars. You always round to the second decimal place because we don't have fractions of a penny in our system. We only have cents. So 4 is 0, 1, 2, 3, 4. It's less than 5. So the 1 stays the same. I don't move that up to a 2. I have my final price of $1.01. All right, so there's a little bit more review on percents and using them, and a little word to the wise about percentage down plus the same percentage up doesn't get you back to where you were. And that's it for this lesson in quantitative reasoning.